Let's take a look at these examples to finish up our lesson. We're going to write equations of each of the lines described. So number 1, a horizontal line passing through the point 2, 4. Okay, horizontal lines have all y coordinates the same and a slope of 0. So we're going to have an equation of the form y equals some constant. In this case, y equals 4. Number 2, a line with slope of 1/2 passing through the point -4, 1. Okay, this point that's given is not the y-intercept. So I'm going to start with point slope form. Y minus y1 equals m times the quantity x minus x1, where x1 and y1 are coordinates of the given point, and m is the slope. So we get y minus 1 equals 1/2 times the quantity x minus -4, and then simplify. So that gives us y minus 1 is equal to 1/2 times the quantity x plus 4. Distribute the 1/2, and we get y minus 1 equals 1/2 x plus 2. And lastly, add 1 to isolate y. Okay, so if it says write your answer in slope-intercept form, here it is, y equals 1/2 x plus 3. And number 3, it says find an equation of the line with the given graph. Okay, so if we first look for the y-intercept, if we can tell that it's a nice integer, in this case it's not because it looks like it's a number between -4 and -5, then we can use it and use slope-intercept form. If I don't know 100% the coordinates of the y-intercept, then I'm going to pick another point that I do know. So I'm going to pick this one, which is at 1, -3, and then this one, which is the x-intercept, is at 3, 0. And we can do one of two things to find the slope. We can count on the graph going from one point to another. So we count the rise, which is 3, and the run, which is 2, and get a slope of 3/2. Another option is to use the slope formula, which is m equals y2 minus y1 over x2 minus x1, which is delta y over delta x, or read as change in y over change in x. So just like we did for finding the midpoint between 2 points or the distance between 2 points in the coordinate plane, we can label these points as x1, y1 and x2, y2. Okay, in this case, y2 is 0, so 0 minus y1, which is -3, over x2 is 3, so 3 minus, and x1 is 1. And then simplify. So 0 minus -3 is +3 over 3 minus 1, which is 2. I will then use point slope form. Again, y minus y1 equals m times the quantity x minus x1, which is really just a modified version of the slope formula. Select either point, so I'll choose the second one, and substitute the x and y into this equation. So y minus 0 equals m, which is 3/2, times the quantity x minus 3. And distribute. So y minus 0 is just y, equals 3/2 x minus 9/2 or minus 4.5. So it turns out that that y-intercept was right in the middle between -4 and -5. If instead I wanted to write the equation of a line that has a slope of -2 and passes through the point 0, 5. This time I'm given the y-intercept. Because the x is 0, I know that 5 is the y-intercept, and the slope is also given. So I'm going to use slope-intercept form. Y equals mx plus b. Okay, in this case, y equals -2x plus 5. So we also want to be able to write equations of parallel and perpendicular lines to a given line. Parallel lines are lines that are in the same plane that never intersect. So you can see they're slanted at the same angle and thus would have the same slope. Perpendicular lines don't have the same slope, but their slopes do have a relationship. And if you multiply them together, most of the time you get -1, which means that if you solve for one of them, m1 is -1 over m2. So for instance, if m2 is 3, I would find m1 by taking -1 over 3. And so another way to say this is we're going to take the opposite reciprocal. So we're given the equation -2x plus 3y equals 9, and I want to know the slope of this given line. So I'll write it in slope-intercept form. So we will first add 2x to each side. That gives me 3y equals 2x plus 9, and then divide both sides by 3. So y equals 2/3 x plus 3. Okay, so that means the slope of the given line is 2/3 the coefficient of x. And for number 1, if I'm writing an equation of a line parallel to the given line, parallel lines have the same slope, so that must mean that this new equation will also have a slope of 2/3. And we're given a point of -5, 4, which is not the y-intercept. So using point slope form, y minus y1, or y minus 4, equals m 2/3 times the quantity x minus x1, or -5. This is an equation of the line. It's not an equation in like simplest form, I would say. So typically we want to write them in slope-intercept form. So simplifying inside the parentheses, we get x minus -5 is x plus 5. Distribute the 2/3 to each of those terms, so that's 2/3 x plus 10/3, and then add 4 to both sides. So because of the fraction, I'm going to do a little scratch work on the side. I wanted to add 10/3 plus 4. So I got a common denominator by multiplying the 4 by 3 over 3. That's 10/3 plus 12/3, and then we can add them to get 22/3. And lastly, we want to write an equation of a line perpendicular to the given line, passing through the point 0, -1. Well, this is the y-intercept, or b, in slope-intercept form, y equals mx plus b. So we've got to decide what our slope is if the given line has a slope of 2/3. Okay, so we'll say m1 is 2/3, M2 is the slope of the line that we're trying to write the equation of, is the opposite reciprocal, so negative 3/2. So lastly, our equation is y equals negative 3/2 x minus 1.